Good morning, everybody. Hope you're doing well. Just to let you know, the plan for today, I'm not sure if Miss Barabo is there. I heard from Mrs. Feenstra that she might be sick. If she is, thank you to whoever is subbing. But just to let you guys know, obviously the test is tomorrow. We did review over that on Monday, and you've got your review questions that you can work on during class today. We'll have a fair amount of time for you to be able to do that. I wanted to go over a brief portion of a few things from section 3.7. Some of it will be review. It'll help with the differential equation stuff that that could be on the exam. Most of it won't. Like I said before, this is on separable differential equations. But I'm hoping this may take maybe 30 minutes, and then you guys will have an opportunity to work on problems for the second half of the class. I will have answer keys available for you to be able to check answers to those review problems there in class. So I think the review problems are also posted on the RenWeb, the answer key for those. So let's just do a little bit from section 3.7, and then I can let you guys go from there. Sorry, not 3.7, 5.7. So this is on separable differential equations. Okay. So there's a couple things I just want to review to make sure that it's super clear, so that you remember. So first of all, a differential equation, these are sometimes abbreviated DE. This is an equation that involves the derivative in some way. It could involve the first derivative, second derivative, etc. So you could have like the sine of the second derivative plus e to the first derivative minus 5 times the original function equals 0. That's an example of a differential equation. Remember that what's unusual about differential equations is the solution is actually a function, or it's multiple functions, rather than typically equations where you're used to the solution being a number. So here the solution is a function. Okay, so the solution is a function or a collection of functions. Remember also that we talked about the order. Let me write a little bigger. Sorry, this is kind of small. Okay, so the solution is a function. And remember that the order of the differential equation is the highest derivative of y that shows up in the differential equation. So in this example here, this is a second order differential equation there. Okay. And we also talked, we reviewed a little bit on Monday the idea of slope field. So this is a situation where you have y prime equals some function of x and y, and then you draw some axes and you just pick points like 0, 0 and plug those in to figure out what the slope should be in various points. And then you try to follow those in drawing some example solutions. Okay, so you've seen some examples of that. We've gone over that before. And typically, like I said, in a differential equation, there's a collection of functions that are all solutions. Sometimes I give you extra information that's called an initial condition, and that produces a specific solution or a particular solution rather than a kind of a collection of solutions. Okay? Now, then we talked about how do we solve differential equations. And just like in the case of algebra, where you solve equations differently depending on the way the equation looks, The same thing is true with differential equations. The way that you solve these differential equations depends on their format, depends on how they look, their form. And so one special kind of differential equations that we're going to run into are separable differential equations. And these are equations of the form some function of y times y prime is some function of x. Okay, and the way that we go about solving these is we use that Leibniz notation and we write y prime as dy over dx, and then we put that dx on the other side, and we integrate both sides. All of this is stuff that we've talked about in the past. This is stuff that can be on the exam. I'm not putting separable differential equations on the exam for Thursday, okay? But I do want to go over a few more examples because that's going to come up then when we talk about some of these things on Monday. All right, so I want to go through 3 examples, and then that's pretty much it. And then I'll let you guys kind of let you loose to work on your review problems. Okay. So let's take as an example x squared plus 4 times y prime equals x times y. Okay? So this is our first example here. X squared plus 4 quantity times y prime equals x times y. So the first thing I need to do is I need to check, is this separable? So I need to try to get all the y's on one side and all the x's on the other. So let's divide the y over. And when you're doing these separable differential equations and you start dividing by y or dividing by some function of y, you need to check and make sure what happens when that's 0. So if y is the constant function 0, notice that y prime would be 0, and that actually solves this equation. So if I plug that in, x squared plus 4 times the 0 function equals x times the 0 function. So y equals 0 is a solution. That's one of the many solutions to this differential equation that we're looking for. Okay, it's not the only one, but it's one of them. So assuming that y is not 0, we can divide by it. So I'm going to make 1 over y. I'll leave the y prime there just for a second. Let's actually turn that y prime into dy over dx. And then I've got my x over here, and I'm going to divide the x squared plus 4 over. Okay? So putting the dx on the other side, what we're left with is 1 over y dy equals x over x squared plus 4 dx. Okay, so this is a separable differential equation, and we're going to deal with it the way that we were talking about over here. With me so far? Got it? All right, 1 over y, the antiderivative of that is natural log of absolute value of y. We don't need a plus c here because we're going to have a plus c over here, and we don't need 2 general constants, so we're only going to put it on one side. Now to do this integral, we need to do what? This type of integral could show up on the exam. In order to do that, we need to do substitution. Okay, so you should notice that the top is basically the derivative of the bottom. So if I let u equal x squared plus 4, then du would be 2x dx, and 1/2 du would be x dx. So substituting in, the x dx is 1/2 du, and this part that's left over gives me 1 over u. So leaving that left side alone, if I pull out that 1/2, this becomes the natural log of the absolute value of u plus some constant. Now I'm going to call it C1, and I'm going to keep changing this constant until I get a general constant at the very end. Okay? So Let's substitute back in for u. So the natural log of the absolute value of y equals 1/2 natural log of x squared plus 4. Now, x squared plus 4 is always positive, so we can actually drop the absolute value if we want to. Now, because I want to solve for y, so because I have a natural log over here, I want to take e to everything. So the e and the natural log over here are going to go away. And I've got e to the 1/2 natural log of, I don't need those absolute value anymore, x squared plus 4 plus c1. And I'm going to separate that out. So that's e to the 1/2 natural log of x squared plus 4 e to the c1. Now, e to any number is positive, so I'm going to rename this constant. We're going to call that d. The other thing I'm going to do, because I have e to, if that 1/2 wasn't there, e to the natural log would cancel. So what I'm going to do is use a rule that you might remember, that if you have, you may remember that if you have natural log of x to the r, you can take r out and put it out front. And you can do the reverse. If you have a number out front, you can stick it up as a power. So I'm going to take that 1/2 and stick it up here as a power. So we've got that d. E to the natural log of x squared plus 4 to the 1/2. And now the e and the natural log cancel, so we actually get d, this thing to the 1/2, which means the square root of x squared plus 4. And d is positive. So now if I drop the absolute value, y equals plus or minus d times that square root. And you'll notice, so that means that d can be any positive, in this case, this constant can be any positive or negative number. But if it's 0, we get that solution. So the general solution is y equals some constant times x squared plus 4 underneath the square root. Okay? So that is my general solution to that differential equation. Makes sense? Any questions? Okay. Let's try our second example here. Xy plus e to the negative x squared times y squared minus 1 times y prime equals 0. Okay? Let me read it again. Xy plus e to the negative x squared times y squared minus 1 times y prime equals 0. So again, the first thing that I'm going to do is I'm going to work on trying to get this thing to have all the y's on one side and x's on the other. So let's put this xy on the other side. So we've got e to the negative x squared times y squared minus 1 times y prime equals negative xy. Now let's move the y over here. Okay, and immediately when I do that, again, when I divide by y, one of the first things you need to ask is what happens if y equals 0. So if y equals 0, then y prime is 0, and so this left side would be 0, because this is 0, and the right side would be 0. So y equals 0 is a solution. And we're going to, just like we did over here when we incorporated that eventually into that constant, we're going to do that with this too. But this at least lets us divide by y. So we're going to put the y on the other side. So we've got y squared minus 1 over y. Let's turn that y prime into dy over dx, because we're eventually going to separate. And e to the minus x squared actually means it's e to the x squared on the bottom, right? Remember, negative exponents mean the thing actually belongs on the bottom. So e to the minus x squared means it's really e to the x squared on the bottom. So I'm going to move it up here. That negative x stays there, but I've got e to the x squared that's sitting there because I brought this down to the bottom, made it e to the x squared, and then moved it over, basically cross multiplied. Okay. So now if I move that dx to the other side, okay, then this is in fact separable. So what I would like you to do is just with your neighbor, just take a minute and talk about how would you do this integral and how would you do this integral. Okay, just take a second and talk with the person next to you. How would you do the first integral? How would you do the second integral? How would you do both of those? You don't have to do it yet. I just want you to kind of come up with a strategy for how you're supposed to proceed. Okay, let's start with the left one. The way I would do this is I would actually do the division. So y squared over y is just y, and 1 over y is just 1 over y. Okay, this is now in a form that I can actually take the integral. What about that right side? What should I do there? You can see me getting my red pen out, which is generally an indication that you're going to do u substitution. So if I let u equal x squared, there are two things that tell me to do a u substitution. I've got a composition here, x squared inside e to the x. And I've also got this x is kind of the derivative of x squared, so the du is sitting right here. So du is 2x dx. We don't have that 2, so let's stick a half over on the other side. So pulling out that negative e to the u, and then x dx is 1/2 du. Okay, so now both of these integrals are in forms that I can actually integrate them. So the y becomes 1/2 y squared. The 1 over y becomes the natural log of the absolute value of y. And then negative 1/2, the antiderivative of e to the u is just e to the u, plus c. Okay. And let's substitute back in so we've at least got x's. So we've got e to the x squared plus c. In this case, there's actually no way to solve for y because of how complicated this left side is. So the way that you would want to answer this, if somebody said, what are all the solutions, you would say anything that satisfies this and also y equals 0. There's no actual way to combine those two answers, in part because you can't take the natural log of 0. So you can't combine those answers. Those would be the two collections of answers for that problem. Okay. All right, let's do one more. Let's do dy over dx equals y over x squared. Okay. So y prime, or dy over dx, equals y over x squared. And clearly, again, this is separable. I'm going to try to put the y's on the left side and the x's on the right. Now, when I do the y's on the left side, I immediately, again, have to consider what happens when y is 0. So if y is 0, the derivative is also 0. And so that works in this equation. So y equals 0 is a solution. y equals 0 is not always a solution, but in these three examples it turns out to be 4. So if y is not 0, then I can divide by it. So I'm going to put 1 over y over here. And I've got 1 over x squared. And let's stick the dx on the right side and leave the dy on the left side. So it is separable. I'm going to integrate both sides. The integral of the left side is the natural log of the absolute value of y. The way we do the right side, remember this is x to the minus 2, so we're gonna go negative x to the minus 1. Okay, remember you add 1 to the power and divide by it. If I add 1 to that power, it's x to the minus 1. If I divide by minus 1, it's the same as multiplying by minus 1. Plus some c, I'm going to call it c1, because I'm going to play with it in a minute. Okay, so I've got negative 1 over x plus a c1. Next step to solve for y is I'm going to take e to both sides. So absolute value of y equals e to the minus 1 over x plus c1, which I'm going to separate into the e to the minus 1 over x, e to the c1. This is now any positive constant, so I'm going to call that d. d e to the minus 1 over x. And now if I drop my absolute value, I get plus or minus any positive constant. So this is any positive or negative constant, but y equals 0 is also a solution, which would be when d is 0. So I'm going to call this c e to the minus 1 over x. So that is my general solution for that differential equation. Okay. And now if I gave you, if additionally, like at the beginning of the problem, or as kind of like a part B, I said when x equals 1, y equals 3, and I said what is the particular solution, then what we would do here is we would plug in y equals 3 and x equals 1, so e to the minus 1, which is 1 over e. So if I put that e to the other side, c is 3e. So my specific solution, this is the general solution, but my specific solution would be 3e times e to the negative 1 over x. That would be my specific solution. Okay. So we finished even this a little bit early. So you've got a fair amount of time now to work on some of those review problems if you haven't already been working on them. You've got some answer keys there. I'd encourage you to work in pairs if you'd like. And if any questions come up between now and the exam tomorrow, you're welcome to email me. Sometimes you can text me. Texting math problems is kind of hard. Emailing math problems isn't that easy either. But you're welcome to explain, tell me, I'm looking at number this, and I'm not exactly sure what to do here, or I tried this, it didn't work, what should I do now? Or I got stuck at this place, okay? All right, I'm praying for you guys as you study. I'm sure you're gonna do great, and I will see you all on Monday, but you have the exam on Thursday, and somebody, I don't know if it's Miss Separable or somebody else, but somebody will be there to administrate it. All right. Happy studying.